All right, now we are going to graph exponential functions using transformations. So basically what we're going to do is take a simple exponential function, meaning you've got a number that's positive, not equal to 1, raised to the x power. So something like we looked at in example 1. You're going to take a simple exponential function and you're just going to use a transformation, one or more transformations on it to get a new graph. Okay. So here in example 2, it says use transformations to graph each function, and then after we graph each function, we're going to state its domain, range, and horizontal asymptote. Okay. All right, so we've got p of x is equal to 3 to the x minus 1 plus 2. Q of x is equal to negative 3 to the x. And then r of x is equal to 3 to the negative x. If you notice, these are all exponential functions. The x is in the power. Okay. All right. To start with, we need our parent function. Now the parent function is going to be different here. We've never done exponential functions prior to this section. So the parent functions that you learned back in section 3.4 don't apply here. Okay. If you look at all three of these functions, each one is some variation of 3 to the x. So that is what our parent function is going to be. So we're going to graph 3 to the x just like we graphed 2 to the x in example 1. And then that will be our parent function. Okay. All right, so let's make a table of values to graph 3 to the x. So I'm going to write here that our parent function is 3 to the x. All right, so let me go ahead and make a table of values just like we did in example 1. All right, so we're in charge of x, and then we're going to plug each x value in to get the y value. All right, so we want to get a good picture. So I'm going to pick 0, something positive, and then we'll pick a couple of negative things. All right, so I'm going to go ahead and plug in x equals 0. We're plugging into 3 to the x. So if I plug in x is 0, I'm going to get 3 to the 0. And we learned in the last example that anything raised to the 0 power is going to give us 1. So the parent function is going to go through 0, 1. And now let's plug in the positive x value. So 3 to the first power is going to be 3. So our graph will go through 1, 3. And now we'll plug in 2 for x. So this is going to be 3 to the second power. That's 3 times itself. That's going to give us 9. So the parent function will go through 2, 9. And now we can plug in the negative values for x. So 3 to the negative 1. We know how to deal with this. I'll come up here and figure it out. 3 to the negative 1 means if you want to eliminate that negative exponent, you do 1 over it and then change the sign of the exponent. So this is going to be 1/3. So our parent function will go through -1, 1/3. And then lastly, we'll plug in -2 for x. So we'll get 3 to the -2. We'll come up to the top and make sense of 3 to the -2. That's going to be 1 over 3 to the -2, but change the sign of the exponent. This is going to be 1 over 3 times 3, so you get 1/9. All right, so our last point here is going to be -2 1/9. So now we have 5 points that we can plot for our parent function. All right, parent function will go through 0, 1, 1, 3, 2, 9, and then the decimals you're just going to have to eyeball. -1, 1/3. Remember, 1/3 is about 0.33. And then -2 1/9. 1/9 is even smaller than 1/3, so it'll be even closer to the x-axis. All right, now 3 to the x is going to have the same basic shape as 2 to the x did. It just goes through different points. Okay, so in this direction, we are climbing very quickly. And in this other direction, we're getting closer and closer to the x-axis without touching it. Okay, so this is the graph of our parent function, 3 to the x. All right, now that we have that, we are going to attempt to graph the first function using transformations. Okay, so we're going to graph p of x is equal to 3 to the x minus 1 plus 2. You do not need to make a table of values to graph this. Okay, you're just going to take your parent function and move it around. It's going to be the same transformation rules that you learned in section 3.5. Okay, all right, so let's see what's going on here. Okay, you got a couple of things going on here. I'm going to put this graph in a different color so we can distinguish it from the parent function. All right, first thing to notice is outside you're adding 2. So remember, if you're adding outside of parentheses, that's a vertical shift. So we're going to go up 2. And then instead of 3 to the x, we have 3 to the x minus 1. So here something else is going on. So this is actually going to be a horizontal shift. You do not have parentheses here. And when we learned the transformation rules, we learned that if you were subtracting or adding inside parentheses, it would be a horizontal shift, either left or right. But the exponent acts like parentheses. The x minus 1 is trapped in that exponent just as parentheses traps whatever's inside. Okay, so you can kind of think of this as being in parentheses, even though they're not visible. The exponent is trapping what's inside. Okay, so it's like you're subtracting inside of parentheses. Okay, so this is going to be a horizontal shift, and since you're subtracting, you're going to go to the right. So we're going to go right 1, up 2. You've got to take into account the order of the transformations. Remember, you should always do them according to the order of operations. Parentheses comes before addition, so you're going to go right 1 first and then up 2. Okay, so each of our points needs to go right 1, up 2. Okay, you can do this separately or you can do it all together. Okay, one thing I want to notice here, and this is a good rule kind of to follow when you're doing these exponential functions, just because they have these horizontal asymptotes. Okay, the horizontal, I'll go ahead and put it because I didn't really put it when we did the original parent function. Parent function has a horizontal asymptote, which is the x-axis. Okay, I'm just kind of drawing it slightly below so you can see it. The x-axis is a horizontal asymptote. It's not, I guess it's not physically part of the graph, but it's there. It's got this horizontal asymptote that it can't cross or touch. So when this red graph moves, think about what happens. The whole graph is going to move as well as the asymptote. So if we shift right first, that does not affect our asymptote, but moving up 2 definitely does. So if you're graphing with transformations, if you're graphing these exponentials with transformations, you really should move. It's in your best interest to move the asymptote first because that will give you a boundary for your graph. Okay, so again, moving right does not impact the asymptote, but moving up 2 does. So when we draw in the red graph, this is going to be its horizontal asymptote. So I'm going to draw this in. This will be a boundary. We cannot cross or touch that boundary line there. Okay. So now let's go ahead and get our specific points. We're going to take each point. We're going to go right 1 and then up 2. I'll start right here because it's just an easy point. So we're going to go right 1, up 2. So it's going to go through, the red graph will go through this point. Okay. And then this point will go right 1, up 2. So this is going to be 2, 5. By the way, this is 1, 3. And then this guy will go right 1, up 2. So this is going to be 3, 11, slightly off the graph. All right, these guys, you're just going to have to kind of eyeball. You're going to go right 1, up 2, so slightly above the dotted line. This guy, right 1, up 2, so above the dotted line, but even closer to it than this other point. All right, and so now we can connect the dots. Okay, so we're going to go through these red dots. One side should still be climbing quickly. The other side should be getting closer and closer to this new asymptote. Okay, it should be leveling off there. Okay. These are 3 specific points the red graph goes through. 1, 3, 2, 5, 3, 11. You don't have to worry about these two writing down specifically what they are. Okay, you're just kind of eyeballing them when you move them. Okay. So that is what our red graph looks like. So this is 3 to the x minus 1 plus 2. All right, so every point went right 1 up 2, and the asymptote moved with it. Now that we have the graph of this function p of x, we're going to go ahead and there's a chart below the picture where we're going to write in the attributes of domain, range, and horizontal asymptote. I didn't have room to actually write this out, so make sure you realize this is the horizontal asymptote. We're going to do this for all 3 graphs in this example. All right, so let's look at the one we just did, 3 to the x minus 1 plus 2. The domain is going to be all real numbers. First of all, I've already discussed with you that the domain of an exponential function is all real numbers. If you look at the graph, the leftmost point, the leftmost x value is -infinity, and then the rightmost point, remember this goes up forever, which corresponds to these x values, okay? So the domain is going to be all real numbers. The range, you want to go from the bottom to the top, but you're going to write down the y values. So your bottommost point, all these points are getting closer and closer to this dotted line. Okay, so your y values are getting closer and closer to 2, but you never actually get to 2. So you're going to go like 2.1, 2.01, 2.00001, but you never actually make it to 2. So your lowest y value will be 2. You don't get there, so you don't include it. But your definite high point is going to be, in the y direction, is going to be +infinity. All right, and then lastly, we need the horizontal asymptote. You have to write down an equation. It cannot be just a number. The horizontal asymptote, the line that your graph is getting closer and closer to without touching, is this dotted line, this red dotted line, okay? Horizontal lines are always y equals, okay? It's going to be y equals 2 here because if you look at specific points on this red dotted line, each one has a y coordinate of 2. So the equation of your horizontal asymptote is y equals 2, okay? So these are the attributes of that graph, okay? That's your graph. And now we will move on and do the next one.